Okay, by popular demand, here's a video about general factoring strategy. So the first thing that you always want to do when you're trying to factor any polynomial is, if you can, you want to take a common factor out of every term in the polynomial. So just as an example, if you had something like x to the 6th plus 3x squared minus 9x or something like that. And actually, just for fun, let's put a 6 in front of that first term as well. You can look at each one of these three terms and you can say, hey, wait a minute, my first step is going to be taking a common factor out of each one of these three terms. It looks like we can take a factor of 3 out, so that common factor can involve numbers. And you can also take an x out. So if you take a 3x out of the first term, you're going to be left with a 2x to the 5th. If you take a 3x out of the second term, you'll be left with a 1x. And if you take a 3x out of the last term, you're just left with a 3. So the very first step when trying to factor is, can you take a common factor out of every single term? If you do that step first, you'll make your life a lot easier. So next step, step 2. If you have 4 terms left in your polynomial, and there aren't any like terms or anything like that, if you have 4 terms in your polynomial and you still want to factor, then it's pretty likely to be a factor by grouping problem. And now just recall, factor by grouping, if you had something like 2x cubed minus 4x squared plus 6x minus 12, you'll notice you have 4 terms, and this is a factor by grouping problem. You group the first 2 terms and the last 2 terms together, and you ask yourself, what can I factor out of those first 2 terms? So you can take a 2x squared out of the first 2 terms. Okay, good. That would leave you with just an x from the first term and just a 2 from the second term, a minus 2. Then you ask yourself, what can I factor out of the next 2 terms? It looks like you can take a 6 out. Make sure you have a plus in between these 2 terms, or else you're missing something. If you take a 6 out of this term here, you're left with an x, and if you take a 6 out of the 12, you're left with a negative 2 again. Now, you'll notice that the 2 terms in parentheses are the same. And if the 2 terms in the parentheses are the same, that means that you can, in fact, complete this factor by grouping problem. Now, if your 2 terms in parentheses were not the same, then either something went wrong or the thing just can't be factored. So you'll notice there's an x minus 2 in each of these 2 terms. If you pulled an x minus 2 out of this first term, you're left with a 2x squared. And if you pulled an x minus 2 out of the second term, you're left with a 6. So that's just a real quick example of how you could do a simple factor by grouping. So in the first example, that was the answer. In the second example, that's the answer. Now, there's another possibility. What if you're factoring and you get down to a polynomial that has 3 terms? Well, there are a couple possibilities here, actually. The first possibility is you have an x squared plus some number x plus c. This would actually probably be the easy case. And an example of that would be, what if you have x squared minus 5x minus 6? Well, all you have to do is recognize that you have yourself 3 terms. It's a trinomial, and whenever you're factoring trinomials, you want to factor that into 2 multiplied binomials. And all you have to do in this case, where there's not a number in front of your x squared, I guess there's technically a 1 there in front of your x squared. Whenever there's a 1 in front of your x squared, this is really easy. All you have to do is come up with 2 numbers that multiply to get this last term here, the c term, but then they add to get this term right here, this b term. So you probably don't have to think about it for too long. Negative 6 and positive 1 multiply to get negative 6, and they add to get negative 5. So that's it. That's all you have to do. Is just find those 2 numbers that multiply to get your last term and add to get your middle term. Well, if you're factoring and you get down to a case where you have 3 terms again, but this time you don't have a 1 in front of your x squared. You actually have a number in front of your x squared that's not 1. It's slightly more complicated. Let's do an example where you have 2x squared plus 5x plus 3. It seemed like the way that you all like to do it in class was to multiply the first and last terms together, the coefficients together. That would be 2 times 3 equals 6. And now you're looking for factors of 6 that are going to add up to this middle term 5. So I like to list my factors, 6 and 1, 2 and 3. You could have -6 and -1 and -2 and -3, of course. So the question is, which of these 4 possibilities, which group of those numbers adds up to the middle term, 5? Well, it's pretty easy to see that 2 plus 3 adds up to 5. So what you do is you copy your first term down, you copy your last term down, and we actually split this middle term up into 2 pieces. How do we know what 2 pieces to use? How do we know that it's 2x plus 3x? Well, we use the coefficients from the factors that added up to the middle term here. So now you have 2x squared plus 2x plus 3x plus 3, and we have ourselves 4 terms now, and this is a factor by grouping. If we group the first 2 terms together and ask what can we factor out, it looks like we get that. You factor out a 2x and are left with an x plus 1. If you look at your last 2 terms, it looks like you can factor out a 3. Again, don't forget your plus in between these 2 terms. Now, you'll notice that you have an x plus 1 and an x plus 1 in parentheses. You can factor that out just as we did before with factoring by grouping. X plus 1. You're going to be left with a 2x from the first term and a plus 3 from the second term. All right, so there's a quick example of a polynomial of 3 terms, also known as a trinomial, that has a non-1 coefficient in front of x squared. So real quick, what have we done so far? Well, we've taken a common factor out of every single term. If we came down to a polynomial that had 4 terms left, we know that it should be a factor by grouping. And if we came down to a polynomial that has 3 terms left, we know that it's going to be factored into 2 binomials. Both of these were factored into 2 binomials. One of them was a really easy case where you just have to find a couple of numbers. And the other way was not too hard either, but you had to start by multiplying your leading coefficient by your constant. Now, there are a couple other cases that we haven't talked yet about in class, but the last possibility here, for the most part with factoring, is what if there are 2 terms left? What if you have 2 terms in your polynomial? Well, there are a few possibilities. You have a difference of squares possibility. What this means is, well, if you have 2 terms that are perfect squares, x squared is a perfect square, clearly, and 9 is a perfect square. That's just 3 squared. And a difference, if you have a difference of those 2 squares, then you can factor that, and we'll talk about how to do that. If you have a difference of cubes, so that would be the case where if you had x cubed minus, say, 27, difference of cubes, you have a perfect cube here, that's just x cubed. You have a perfect cube there, 27 is just 3 cubed, and you have a difference of those cubes, then you can factor that using a technique that we'll talk about in class. The last possibility, if you have 2 terms in the polynomial that you're trying to factor, is it could be a sum of cubes. This would be the same example as before. You have 2 things that are perfect cubes, but they're summed, they're added together this time. You can factor that using a technique. So that's it. That is a general strategy for factoring, I would say 99% of the polynomials that we're going to see in our class. Take out a common factor, always do that, and then you can kind of break it down. You can say, are there 4 terms, are there 3 terms, or are there 2 terms? And then you can go from there. All right, guys, I will see y'all on Thursday.